So they're giving us an example where x equals sine of t. Now notice they've switched these round, but it doesn't actually change what happens. I'll show you in a minute though what it does to the curve and the way that it draws it. If I put that into my equation over here, we get the shift offsets by the 2 and the -3. That's the first part. Notice the direction that when I do cos t first, cos t I said, when I start with my 0 and look at the direction in which it draws the graph, it goes round from the 0, increasing until we get all the way around. That's from 0 to 2 pi. If I swap these over, the order it works on changes. So now I still get a circle, but now notice it's starting at the top. And because I've switched the x and the y axes, it's the same as doing the inverse. I'm drawing it the other way around. I'm reflecting in the y equals x graph now. So if I double the top, again, what's going to happen is I'm going to stretch this 2 in that direction. Sorry, in the x direction still, because that's in the 2. If I move the t, which was with the cos in the y direction, that's now moved so that we have our equation. So we've swapped our x and y. It's a reflection in y equals x. A reflection in y equals x will also swap the order in which things happen. Okay, so sine t. Let's just find the point they've done it, and then we'll find the equation in a minute and link that to some values. So there's my graph. Just move it a little bit. Take a copy. So this is what we're actually drawing. Now we actually want to find out what the Cartesian equation is. So we need to rearrange this into a form that we can use. Well, of course, we need to think of a link between sine and cos, and we want sine squared theta plus cos squared t is 1 is a nice little starting point. Trig identity. So sine t equals x minus 1, minus 2, and cos t gives me y plus 3. Put them into the equation. So this has moved the x direction plus 2, y direction down 3. Put them in now, and we've got x minus 2 all squared plus y minus add on 3 all squared is equal to 1. And if you're familiar with the more general form of the circle equation, you have x minus x naught, the centre, squared, plus y minus the y naught, the centre, squared, is equal to the radius squared. That's a more general offset circle. So if you can spot those notes, you can rearrange it to create the equations. So we've got our the equation that they would like. That's what they would like it. They'd like us to sketch it. And one thing that I was asked to have a look at, let's have a look at the domain. Let's look at the domain of this function. So we're saying that our value of t is between 0 and up to 2 pi. So let's look at the limits first of all for our x. So x at 0 gives me sine of 0 plus 2, which means I've got one limit point at 2, and that's included. If I do x as 2 pi, sine of 2 pi again is 0 plus 2 gives me a limit of 2. If you want to find out what's happening in between, I'm not sure if we're greater than or less than that at the moment, so don't know what's going on with this compared to 2. What we can look for is a value in between. Let's see what happens when x is pi over 2. That's sine of pi over 2. Sine of pi over 2 plus 1. Pi over 2, plus 2, sorry. Sine of pi over 2 is equal to 1. So we get a value of 3. So we now know this is going up to 3. This was incorrect. Well, if we're checking our limits, let's do dx dt then. We want dx dt, differentiate the sine of x, and we get cos t. Differentiate the plus 2, nothing. This is where we were talking about assuming. I'm going to assume that there are other solutions. So when we do this domain, cos of t equals 0. What values of t make cos 0? If you go back to your cos sine or your curve, we've got values here and here of pi over 2 and 3 pi over 2. Or cos is 0 at this angle, which is pi over 2, and this angle all the way around here, 3 pi over 2. So we get t can either be pi over 2 or 3 pi over 2. Put those into my equations. So x at pi over 2 is the sine of pi over 2. Sine of pi over 2 is 1. 1 plus 2, which equals 3. If I find the other end of the domain, the x, and we've got pi, so t was pi over 2, and this t is 3 pi over 2. We're in between our limits, 0 and 2 pi. We now get our domain coming out of these equations. Sine of 3 pi over 2 is minus 1. So minus 1 plus 2 gives me a minimum value at 1. So we now know the domain of x, t is between 1 and 3 using these values. The actual limits here weren't helpful. Okay, so that's about the domains of these values. That's your first simple example. Okay, let's do